Good morning, everyone. Welcome to our very first lecture in Enhancement Chemistry Course Pack 1, Lesson 1. This morning, we're going to talk about Introduction to Chemistry, and here are the following specific learning outcomes. At the end of the lesson, the students are expected to 1. Define chemistry, 2. Cite the importance of chemistry, 3. Give examples of useful chemicals used in daily life, 4. Give examples of careers related to chemistry, 5. Cite the importance of periodic table of elements, 6. Differentiate between atomic number and atomic mass, 7. Identify the categories or groups in the periodic table of elements, and 8. Recite orally the first 50 elements in the periodic table through video recording. Alright, so without further ado, let's read this motivation or prompting questions first. As we study lesson 1, you will learn what is chemistry, why is it considered as the central science, and in our daily life, can you cite instances where chemistry's importance is demonstrated? And next, who devised the periodic table of elements? What do you think is the significance of the periodic table? And lastly, among the careers related to chemistry, cite 3 careers which you find most important careers that needs to be serious in studying chemistry before practicing their profession. Alright, are you ready? So let's go and learn something new. Chemistry is the study of composition, structure, properties, and interactions. In chemistry, we study what chemicals are made of and what are their properties, how elements interact with each other, and how to use this knowledge to produce useful new chemicals. So actually, chemistry is an incredibly fascinating field of study. Because it is so fundamental to our world, chemistry plays a role in everyone's lives and touches almost every aspect of our existence in some way. Okay, so why do we need to study chemistry? It's because chemistry is essential for meeting our basic needs of food, clothing, shelter, health, energy, clean air, water, and soil. In addition, chemical technologies enrich our quality of life in numerous ways by providing new solutions to problems in health, materials, and energy usage. Thus, studying chemistry is useful in preparing us for the real world. Chemistry is often referred to as the central science. Why do you think so? Why is it considered as the central science? It's because chemistry joins together physics and mathematics, biology and medicine, and the earth and environmental sciences. Alright, I know you are very familiar with biology. You have taken that in the first semester, like enhancement biology. And right now, you're also enrolled in environmental science, and you also have a subject in mathematics and physics. So what you're going to learn about chemistry, you are going to apply the concepts that you have learned in chemistry to physics, mathematics, biology, and the environmental sciences. So knowledge of the nature of chemicals and chemical processes therefore provides insights into a variety of physical and biological phenomena. Okay, so that's it. That is why chemistry is considered as the central science. Alright, so in addition to the importance of chemistry in our daily life, chemistry involves the study of how different substances change colors, shape, size, and their forms when reacted with another material or a set of substances. So later on, we're going to tackle about chemical change and physical change, and you will understand further the difference between the two and what are the techniques in identifying their differences. All right. So lastly, understanding chemistry in everyday life is important because the food we eat, the cosmetics we use, or the medicines we take, all of these undergo chemical reactions. It can help you make decisions related to a wide range of things like watering plants based on seasons, setting the temperature to bake a cake, choosing the right medicine for acidity, applying a particular SPF sunscreen, and etc. And lastly, It helps you understand which element does your body needs more. For instance, some may require vitamin D more than the others, alright? Now, you are studying enhancement chemistry this semester, right? Then some BS forestry students are also taking organic chemistry together with enhancement chemistry. And the second year students, which are the agriculture students right now, they are taking general biochemistry. So what you have learned in enhancement chemistry, you will be able to use that in studying organic chemistry and biochemistry. So I want you to be serious in studying the lessons in chemistry, as this will be useful as you go over higher related chemistry subjects. Alright, so let's go to the next slide. Okay, so let's continue. Here are a few examples of the chemicals formulated by chemists, and until today, these chemicals are very useful in our daily life. First one, you have the medicines, and the next, fertilizers, and the next one, glass and optical fibers, preservatives, cement, concrete and glass, cosmetic products, detergent and fabric softeners. Next slide is showing you the chemistry-related careers such as doctor, chemical engineer, food technologist, geologist, pharmacist, nutritionist, forensic scientist, and biochemist. Now let us discuss what do these people do. Okay, so a doctor is a person with a medical degree whose job is to treat people who are ill or hurt. The next one, we have chemical engineers. Chemical engineers apply the principles of chemistry, biology, physics, and math to solve problems that involve the use of fuels, drugs, food, and many other products. Chemical engineers work mostly in offices or laboratories. They may spend their time at industrial plants, refineries, and other locations where they monitor or direct operations or solve on-site problems. Next one is food technologist. A food technologist is also known as a food scientist. Okay, so food technologist is someone who works in the food processing industry and works to help develop healthy, safe, and convenient food products. Okay, so the food technologists continually work to develop better methods of food preservation, better processing and packaging procedures, better storage, and even better delivery processes. And the next one, we have the geologist. A geologist is a scientist who studies solid, liquid, and gaseous matter that constitutes the Earth and other terrestrial planets, as well as the processes that shape them. Geologists also have a background in physics, chemistry, biology, and other sciences. The next one is the pharmacist. A pharmacist are healthcare professionals who specialize in the right way to use, store, preserve, and provide medicine. Pharmacists guide you on how to use medications and let you know about any potential adverse effects of what you take. They fill prescriptions issued by doctors and other healthcare professionals. Next, we have the nutritionist. A nutritionist is a person who advises others on matters of food and nutrition and their impacts on health. Some people specialize in particular areas such as sports nutrition, public health, or animal nutrition, and other disciplines. In many countries, a person can claim to be a nutritionist even without any training, education, or professional license, in contrast to a dietitian who has a university degree, professional license, and certification for professional practice. Okay, we also have forensic scientists. A forensic scientist, or sometimes called forensic science technician, identifies, collects, and examines physical evidence found at a crime scene. So you are very familiar with SOCO, diba? So some of the scientists there that studies the evidences gathered from the crime scene, they are called forensic scientists. Okay, so their main duty is to include analyzing and interpreting blood spatter patterns rather, and making observations of crime based on autopsies and taking photographs and videos of victims and crimes. And lastly is the biochemist. Biochemists study the chemical and physical properties of living things and biological processes. Biochemists work in laboratories and offices to conduct experiments and analyze the results. Okay, so from the word bio and chemistry, biochemist applies what they have learned in biology in chemistry, since biochemistry is actually a combination of biology and chemistry word. But in reality, biochemistry is actually a discipline in biology. Okay, so let us proceed. In learning chemistry, you must have a strong foundation in familiarizing the elements in the periodic table. But what does the periodic table of elements actually mean? In chemistry, it is the organized array of all the chemical elements in order of increasing atomic number. So let me just show you. Here is your periodic table of elements. So what you can see, you have the atomic number 1, hydrogen. Atomic number 2, we have helium. Okay, and atomic number 3, we have lithium. So, when the chemical elements are thus arranged, there is a recurring pattern called the periodic law in their properties, in which elements in the same column, okay, so what you can see, column, you call that a group. And these groups have several properties. So without these elements, there will be no useful chemicals to be synthesized. So why do you think so? Because elements are the simplest substance in chemistry. Without this, we will not be able to synthesize any new useful chemicals. Alright, for example, you will combine calcium plus the element sulfur, so Ca plus S, then you will be able to produce a chemical called calcium sulfide. Alright, so imagine without the element calcium, without the element sulfur, will we be able to form calcium sulfide? Of course not. So we need these elements in order to synthesize useful chemicals. The chemicals that has been mentioned previously were the results of the combination of two or more elements. Now, who devised the periodic table of elements? So we have the Russian chemist Dmitry Mendeleev. Dmitry Mendeleev devised the periodic classification of the chemical elements, in which the elements were arranged in order of increasing atomic number and atomic weight. Okay, so let's go back with this periodic table of elements. So look at that one. The one that it is in column, okay? The one that it is in column, that one, okay? You call that group. Okay, you call that group. And this group, as what I have mentioned previously, they have some similar properties. And how about the element in a row? Okay, elements in a row, you call that period, right? You call that period. Now look at the different colors in our periodic table of elements. So those colors are actually indicating different groups. So you have your groups of alkaline metals, alkaline earth metals, transition metals, other metals, and other non-metals. And we also have halogens, noble gases, rare earth elements, and actinoid element. Now look at that one, alkaline metals. So look at the color of the alkaline metals. So we have the element number 3, 11, 19, 37, 55, and 87. So you have the lithium, sodium, potassium, rubidium, cesium, and so on. And we also have the alkaline earth metals. Okay, we have the atomic number 4, 12, 20, 38, 56, and 88. So what is Be? That is beryllium. Mg, magnesium. Ca, that is calcium. Okay, and so on and so forth. And we also have the transition metal that is colored purple. We have 23, 24, 25, 26, 27, 28, 29, 30, down to 40 to 48, 72 rather, to 80, and 104 to 112. And we have the titanium, vanadium, chromium, magnesium, iron, Fe, iron is Fe, CO, cobalt, nickel, copper, and zinc, and so on and so forth. In other, we have halogens. Halogens is, we have 9, 17, 35, 53, 85, 117. So what is F? F is fluorine, Cl is chlorine, Br is bromine, I is iodine, and so on and so forth. And we also have the noble gases, okay, that is colored white. We have the atomic number 2, 10, 18, 36, 54, 86, and 118. Okay, we have He, that is helium, Ne, neon, Ar, that is argon, Kr, that is krypton, and so on and so forth. The periodic table is the most important chemistry reference there is. Why? Because it arranges all the known elements in an informative array. So as what you have observed, elements are arranged according to increasing atomic number. And as what we have mentioned previously, it is also arranged according to its atomic weight. Elements are arranged left to right and top to bottom in order of increasing atomic number. Order generally coincides with increasing atomic mass. So again, let me just repeat. The elements that are in column, you call that groups, and those groups are alkali metals, alkaline earth metals, transition metals, metals and nonmetals, and we have halogens, noble gases, rare earth metals, and actinoid element. And the element in a horizontal row, okay, that's what you call the period. Okay, elements. Science has come a long way since Aristotle's theory of air, water, fire, and earth. Scientists have identified 90 natural occurring elements and created about 28 others. The elements alone or in combinations make up our bodies, our world, our sun, and in fact the entire universe. So that is why I said elements is the simplest substance that cannot be broken down into smaller molecules. Without these elements, we will not be able to synthesize new useful chemicals. The most abundant element in the Earth's crust is oxygen. Okay, did you know that? So, as what you can see in our illustration, there is 46.6% of oxygen. And where can we find oxygen? Oxygen is everywhere in our atmosphere. It's in our air. It's the air that we breathe. And how is oxygen produced? Okay, oxygen is produced through the process called photosynthesis.